Thanks. I'm so excited to be here. I really appreciate that John was able to fit me in. So, this is a talk that I actually prepared for the Melbourne SRE meetup. And so I hope that you guys will enjoy a little bit of an insight into some of the stuff that we do behind the scenes at Octopus Deploy to keep everything safe and to keep you guys, working well. Cool. So what I'm going to talk about is a massive refactor that we did recently where we basically refactored everything everywhere all at once and how we tried to release that really, really safely. So just to give you a little bit of context for this talk, because we're going to zoom in and then we're going to zoom out again. First of all, I'm going to give you some of the context about Octopus Cloud in particular and how that works. I'm gonna do some scaremongering about what releasing a large-scale rewrite can be like in some of the ways that I've certainly done it wrong. And then I'm going to talk you through the things that my team decided we wanted to do this time. Like, what does a really good large-scale refactor release look like when it's happy? And that led us to some quite interesting principles, this mix of our constraint, the constraint of the interesting Octopus context, plus the way we wanted it to go. And so then I'm going to tell you exactly how we did it. And then I'm going to go through and sort of connect what we did to our solution to explain it a little bit. And then I'm going to talk a little bit about hopefully how this, what you can take away from this, right? What might be interesting for you, given you probably don't have an identical context. And I'll finish up with a little bit of how it's going. Awesome. So, Octopus Deploy is actually a 15-year-old product. And I'm sure most of you will be aware that in the last 15 years in the technology industry, we have learned a lot of things about how we build resilient and scalable systems. And so we wanted to rewrite the core engine of Octopus Deploy, the what we call the deployment pipeline, the thing that actually executes the deployments that you guys are doing on our software hundreds of thousands of times a day, sometimes. So we wanted it to be event-driven, and particularly we wanted to use an event-driven system because it gave us these really great properties of resiliency and scalability. Now, I'm showing you the slide. You do not need to grok this slide. I found the slide when I was going through our really beautiful custom presentation templates. This is a slide that our sales team uses to explain what we do, all the different things that we do. And what I really want you to take in from the slide is the absolute chaos of the slide. There is so much on the slide. So when I'm talking about a deployment capability, and when I'm talking about refactoring our deployment pipeline, what I'm meaning is rebuilding or refactoring all of these different features, like taking things from Jenkins or GitLab and deploying to any different cloud thing, maybe running some Terraform. We're currently working on SSH targets, all that sort of stuff. And so again, maybe you guys don't need this context. This talk was originally written for an SRE meetup context where they might not be that familiar with Octopus. This is another default slide template slide where you can see that Octopus Deploy just kind of sits in the middle here of you can connect up so many things. We can take your artifact, however you want to define that thing, and we can help you put it anywhere at all, basically. So see how we are the common bit in between. So I'm going to talk about that pipeline of how we do an actual deployment. So TLDR, deployments are complex. And when I was speaking to the group of SREs, I know all of you are amazing and you use Octopus because you see the value in not having a 10,000 line bash script that has a million different branching paths to run your deployments, right? But to be clear, the kind of deployments here that I'm talking about are basically Turing complete. They're just wildly complex. So Octopus Cloud, we run Octopus Cloud in a single tenant model. So every single customer has their own instance. We run that as a Kubernetes pod. And they also have their own database. We tend to run the databases on an Elastic shared cluster. And this sort of architecture gives us really, really nice safety and isolation for our customers. But one of the things that becomes really, really interesting about this is because there are thousands of cloud customer instances, And because deployments are this wildly complex, wildly varied beast, remember this has been running for like 15 years, we wrote a lot of deployment features in that time, guys. There's a lot of stuff in there. The reason this talk is called Everything Everywhere All at Once is because our customers can do so many different things, it can be extremely hard for us to extrapolate out usage patterns. So we struggle to define really, really clear and useful archetypes, right? Our customers use all of our features everywhere, all the time. We do not really get a break from customer usage or any of that sort of stuff. And additional context that is going to be important as we go through this talk. Octopus Cloud is not a set of microservices. We have a majestic monolith, a well-factored monolith, I would say, right? So each of those instances is essentially running only a single application process, the Octopus server application process, the very same one, the very same binary that you will run self-hosted Octopus for if you are running self-hosted Octopus. So one of the ways that I have released a big refactor in the past has been something akin to a Big Bang release, right? And those have gone wrong in a myriad of ways for me. They tend to be a little bit risky. So things that I personally have seen, a Big Bang release where you have more problems that you can fix. Something where you have chosen to do some sort of one-way door, where you can't actually get customers back to the stability where things were working before. Often if you release large chunks of stuff quickly, or you're releasing like a new architecture that is a significant rewrite, you will have intermittent problems, and they're really hard to diagnose because you're not familiar with how everything is operating yet. And finally, customers are sometimes upset at things being changed. And, you know, if any of these things were happening to me as a customer, you know, if my bugs weren't getting fixed, if I was in a broken state and the developers were telling me that I was just going to have to wait for weeks to get it better, or if there were intermittent problems that the team didn't seem to know what to do about, I would be not too happy either, right? So I think one of the really important things to note for our customers is we understand the trust that our customers place in us. Deployments tend to be mission critical for any business, right? Particularly your production deployments, and the level of trust that they have in us to allow us to connect to their secure production systems. We take those things really, really seriously, right? And so these were the principles that we came up with to try to, I guess, deserve the level of trust, or make sure our customers can trust us the way that we think they should, right? So one of the things that we went through was we're doing this big rewrite. One of the ways that Octopus often releases features is we do a GA. And customers, especially for some of our super cool like Kubernetes stuff, maybe our ephemeral environments things, these really exciting features, our customers are excited to participate in the GA. Some people love being early adopters. They want to try stuff out and they give us really great feedback. That's a hard sell when the feature that we're giving you is scalability, performance, resiliency. We had a feeling that if we tried to get customers to opt into a GA of resiliency, for example, our customers were going to tell us to piss off. Fair enough, because you should expect us just to give you those things. Those are the base level expectation that you should have for us. So we didn't think a GA was going to be a good option. And at the end of the day, we think you guys should expect it from us. And one of the things that has driven us all up the wall before is trying to force a customer to understand some internal property of the system, of how they build and operate the system, that doesn't matter to me as a customer. So I don't know about you, but I suspect you will have had a similar experience where you use a tool, perhaps one that you don't use that often, and for some reason, you can't use a certain feature. Not because you're not on the right tier, not because they're trying to squeeze money out of you, but because you built something up 5 years ago and they've since switched to V2 of their tool, but they expect you to manually migrate. They want you to take on the mental complexity of them running these things. So we didn't want to do that to our customers either. Deployments are hard enough as it is. In a perfect world, your deployments are going perfectly. You shouldn't need to know how Octopus is doing in the background, right? The next principle that we came up with was customer deployments don't fail twice. Got a little asterisk there. We can argue about whether we achieved that and whether that's exactly what it meant, but this just comes back to what I said before. Deployments are mission critical. We can't tell what a production deployment is. One of my favorite stories from a very good friend who was a DevOps consultant for a couple of years was that they had this customer who were doing a lot of work with sort of resiliency in some of their environments, particularly in their test and production environments, not so much in the UAT or horse environments. And we all just had so many questions about what the horse environment was. So look, there is, if you think about it really, unless you very conveniently call an environment production or tell us in some way, we don't have any way of knowing what's really mission critical for you and what's not. So we have to default to treating everything you do as mission critical. And I don't think that's a bad thing. So then switching to look a little bit more internally for the experience as someone working on the Octopus codebase. Octopus continuous delivery. We wanted our devs to be able to ship continuously. This is kind of important, right? We do what we say, basically. So we wanted to make sure that we were getting our developers feedback on this new pipeline that they were rewriting, not right at the end, not in a big bang release once everything was ready to go. We wanted to get feedback as early as possible to make sure that all of the things that we thought it was going to do were going to work. And finally, remember how I said we had thousands of cloud instances? That already can make understanding the state of your cloud, of your cloud environments quite hard, because of course all of those thousands of instances are not going to be on the exact same version of your code at the same time. So we wanted to make sure that whatever we were doing, it was easy for our developers to reason about, to understand, hey, if this customer hit this problem, what was the state of their instance at the time? What version of the code were they running? How were they using the new pipeline, basically? Cool. So the solution, as promised, we called it the Enthusiastic Execution Pipeline Selector, and because I'm a sucker for a cute nickname, we called it EAPS. So if I say EAPS, just know that I'm referring to this particular piece of software that we built. So in this SRE meetup context, I sort of joked a little bit, right? I'm a software engineer. I'm a lead engineer here at Octopus Deploy. And so unlike a lot of SREs or DevOps folks, my solution to the problem was just to write more software. And so we wrote this thing called EAPS. So we called it the Enthusiastic Execution Pipeline Selector. And remember, the execution pipeline is the thing that actually knows how to run your deployments. It's enthusiastic because it will try to run as much, every single deployment that it can on our new V2 pipeline, unless for some reason it has to run it back on our previous pipeline. So, we wanted to get as much feedback on the new pipeline as possible. So we wanted this kind of enthusiastic paradigm where we were running as much stuff on it as possible, as early as possible. This led to one of the conclusions being essentially that we had to maintain both the V1 pipeline and the rewritten V2 pipeline inside that same monolithic code base at the same time in order to enable this switchy behavior. Cool. So here's a little diagram that just digs a little bit more into how EAPS works. So rather than analyzing something like a whole customer instance or anything higher level, this thing runs every time you hit the deploy button. EAPS kicks in, and it has a few different, 3 different features really. It has feature analysis, so it knows what deployment features that you might be using. And remember, we spoke about this before. So this might be something like upload to S3. This might be something like a Kubernetes target. It might be something like an offline drop. It understands the different capabilities the Octopus server has, and it knows which features that a given deployment at the point that that deployment is run is using. And so it analyzes that. It kicks into the selector mode, which decides to run that deployment on the V1 pipeline or the V2 pipeline, always preferring the V2 pipeline. And then once that deployment has completed, it does some anomaly detection. So when I say an anomaly, we were looking for a few different things. It looks to say, hey, did this deployment use a feature that I didn't detect in my analysis? So basically checking that our analysis was working. It checked for the runtime of the deployment to say, hey, if you ran on the V2 pipeline, did you take a really, really long time? Did something go wrong in some way that perhaps wasn't an exception or caused the deployment to break, but was still not acceptable for our customers? Or did the deployment actually fail? Did something go wrong during the deployment? So those are the three components of what EAPS does. So digging into that first principle that customers should expect resiliency, scalability, and performance by default, and particularly they shouldn't have to be aware of the V2 pipeline. They shouldn't have to, when they are building their deployment pipelines, try to build in this new world. Everything should just continue to work exactly the same as it did before, but a little bit more resilient over in the new world. This led us to the conclusion of EAPS. This was one of the things that led to that pipeline selector part, so the part that picks V1 or V2. So given that we had thousands of customers, and each of them can have hundreds of customers, remember customers running everything everywhere all at once, we decided that there could not be a human in the loop. There had to be a piece of software that was responsible for making those decisions. So the context specific to Octopus Deploy that may be different in your world was that deployments are this kind of long-running background work. Once you hit that deploy button, a deployment goes off and it's doing the work. It is showing you output, but it's not really interacting with you very much. We do have some steps that are a bit more interactive, but on the whole, it's kind of this autonomous process that kicks off and does stuff. And so that nature, where it's actually really long-running, really complex operation, that lent itself quite well to this kind of selector idea where you are either all in on V1 or you're all in on V2, and we determine that up front, right? For a lot of sort of applications that tend to lean more on like CRUD operations, not long-running kind of processes, this kind of paradigm of runs in V1 or runs in V2 might not make as much sense. Our second principle, customer deployments don't fail twice, right? And this is kind of trying to mitigate that failure mode that we talked about before, of this kind of one-way door where a customer might get stuck on the new pipeline. If we do a migration, if their deployment doesn't work, we've migrated them to the V2 pipeline and we can't easily switch them back to the V1 pipeline, that leaves them in a broken state. And for their mission critical production deployments, which remember is all of them, we don't want that. So we needed to make sure that there wasn't going to be a human in the loop having to bring them back into safety, and that that it wasn't a one-way door, right? And so to implement this is what led us to the decision of building the EAPS anomaly detection, so that we knew if it was going wrong, and also the pipeline selector part, right? And I sort of mentioned before that to do this, we maintained the V1 code in parallel with the V2 code. That's a not insignificant burden on our developers, but we found it to be worth it for the safety of being able to say, if a customer fails, we have a safe place to send them back to. We know where we can send them back to, and we know that V1 is going to work because we're not changing V1, we're keeping that intact as we go. Cool. And so some of the useful context for this, for Octopus Deploy, is that for us trying to figure out if a deployment if a customer is having a bad time, if a deployment failed, deployments inherently have a pass-fail quality, right? Your deployment will you'll get a green tick or a red cross when your deployment completes. So it was very convenient for us that we didn't also have to build analysis of whether a customer is having a bad time, because the deployment itself can tell us. There's a little caveat here that if we have time for questions later, ask me about it and I can dig into, because this one is really interesting about what does a customer's deployment being successful actually mean. Cool. So the third principle that we went through was that internally our developers can ship continuously and get feedback early. So we are constantly upgrading our customer instances. And in fact, part of the reason that we ran this project was that we wanted to be able to upgrade customer instances more frequently without having any kind of sort of downtime for the customer. And so, yeah, our developers needed to be shipping continuously and getting early feedback on the V2 pipeline as soon as possible to ensure that we knew that it was going to do what we thought it was going to do. This led us to two of the EAPS features. Again, that feature analysis one, and then the pipeline selector. So the feature analysis thing, understanding what a customer's deployment does at the point that it's run, allowed us to defer our decision about which pipeline that it was going to run on up until the very last second, right? Up until the point that they actually hit run. And so this meant that as we ship new versions of the code, because it was the code that was deciding what pipeline to run on, it knew what version it was running and it knew what it supported and what it didn't. And so this gave us the best possible chance of automatically opting customers into V2 and of allowing us to easily kind of start using new features as we developed them, right? So yeah, the next part, the selector, this allowed us some level of safety, because one of the things that we did was we toggled that selector behavior. So remember, we would run the feature analysis, we'd say, can it work on V2? If it can, it does. It would then go into the selector that would usually select V2 in that case. We could toggle that off. We could just say, hey, if one customer has failed for some reason, we will stop all customers running on V2. We'll send them back to safety. And so this gave us a safety net to have some confidence that developers could ship, which is slightly higher risk, knowing that we had a place of safety to send our customers back to if we started being concerned about any impact to customers. And so again, the context for that is this kind of single tenanted cloud environment where they are their own little world, and it's very hard for us to kind of reason about all of the customer instances at once when they might all be running different versions of the code, right? And that's part of why we tied the decision of what to run to what code was actually running on the instance at the time. The final principle, our developers can understand the state of each customer instance. Stuff is going to go wrong. We need to be able to understand what state they were in and why things went wrong, basically. And so again, this is where the feature analysis kind of thing came in. And a little bit that sort of top level feature flag that I talked about, the one that controlled the select behavior. One of the things that we were keenly trying to avoid here was a Cartesian explosion of feature flags. So we had hundreds of different deployment capabilities that we were rewriting to work in the V2 style. If you imagine trying to understand the state of a particular customer instance where they may or may not have a feature flag enabled, may or may not have a selection of, let's say, 100 different feature flags enabled across maybe 10 different deployment processes in their one instance, across thousands of customers, that kind of explosion of possibilities, of combinations, made it really, really hard. So having the feature analysis and the decision tied to the code meant that it was very easy for us to say the state of a customer's instance, the state of these decisions, is in the code. And so I can look at the version of the customer's instance when something goes wrong. And by looking at that version, I will know all the information I need is inside the code, basically. And of course, we paired this with a whole lot of monitoring, alerting, and telemetry as well. Yes. So I think I just explained the part that was meant to go with the slide on the previous slide. You get the picture. So why did this work for us? What's going to be different in your world, perhaps? So the things that enabled us to take this approach were the fact that we decided this really, really early on. When we were very early in this event-driven rewrite, we said, essentially, we want to start thinking about how we release this now, and we want to start getting feedback early. If we had already progressed further along the path, if we had already started releasing when we came up with these principles, it would have been a lot harder for us to retrofit on the kind of approach that we ended up taking. And we looked at the constraints first as well. We looked at stuff like, we don't want a one-way door. We don't want customer deployments to fail twice. We don't want to force customers to think or even know about the V2 pipeline if they don't have to. So having those things that we didn't want helped us decide what we do want, which then led to us deciding what we needed to build. And we had quite a large team. We had a lot of developers available to write this code and to manage this code. If you didn't have as many devs on your team, if you didn't have as much time available for developers to write code to manage something like this might be a little bit harder to do. And all of this is very dependent on the fact that this is a monolith. If this was a microservices world, I think we would probably be talking about a very, very different approach indeed. And finally, I flattered our monolith. I said it was majestic and well factored. It's true that there were very, very good boundaries in our code that enabled us to slot EAPs in at the boundary between at the point that the customer went to run the deployment, right? We were able to essentially snapshot it and control running a deployment with relatively little code change because the boundaries in the code were pretty good. Otherwise, it would have been very hard to kind of add a gate in there. So yeah, I've really enjoyed the way that we thought about safety first up front. And I think I would use something like this approach again if I were doing a large scale rewrite again. So a few numbers for you. As of doing this talk maybe a month ago, a couple of weeks ago, we had 80% of deployments were compatible with V2. And so remember, that's deployments by volume. It's not deployment process, it's volume of processes that run on V2. Of that, we have about 65% of actual deployments running on V2. And just the fact that we can give you these percentage numbers that we are doing it per deployment execution, I think is a really interesting way of looking at it, because we're not talking about a customer or a particular process. We're actually looking at the volume of execution. And overall, I would say we have about 110% developer satisfaction. The team feel like this has given them the control that they needed and the tools that they needed to do this as safely as we could. So thank you all for your time. And I hope you've enjoyed this little insight into the world of Octopus Deploy.